Okay, but before I talk about what we're going to do for the future of GWT, I want to kind of take you back to the era in which GWT was created and the reasons for why it was created. And so, if you go back to 2006, when the first GWT release happened, you think about the web apps that existed back then. Gmail and Google Maps had just come out. And prior to that, people really didn't imagine that you could build super rich applications on the client side. People thought JavaScript was like for form validation. You could do like small bits of stuff with it, but no one ever thought about creating like a really giant application with it. And sort of Gmail and Google Maps gave people this idea that you could build this new generation of applications. But there was a problem, which was there was a massive difference in browser capabilities between things like IE 5 or 6 and Safari 2 and whatever Firefox version there was right now. And it really made it hard to write one application and it worked on most of those things. And so part of the reason for GWT to exist was to actually kind of create a stable platform above that sort of chaos so that you guys could be more productive. And I think we succeeded. A lot of people, wrote GWT applications and they didn't have to spend endless hours figuring out how to make a layout or, handle a keyboard event on Internet Explorer versus Firefox. And so I thought that was great. Also, in 2006, JavaScript was a lot slower. And the browsers were much less capable back then. So talk a little bit about that. How has speed changed, for example? Well, the Kraken benchmark run on Firefox 3.5 versus Chrome 3 compared to Chrome 32 and Firefox 25 is 2,200% faster on the latest browsers. That's an incredible jump in only 7 years. And so you can imagine that allows you to do a lot more amazing stuff on the client. Google spreadsheets being an example, but people are doing like 3D shooter games for the browser now. So JavaScript's got a lot faster, first of all. But the second thing is the capabilities that are built into the browser platform itself have grown by leaps and bounds. A couple years ago, if you wanted to do anything that had to do with video or audio or the camera or something like that, you had to drop in like a Flash component to actually get anything to work. These days, the latest browser has video capability, audio, you can get access to the camera, the microphone, you can make peer-to-peer connections and actually do like Skype-like applications. You have 2D canvas drawing, SVG, WebGL, it's just insane. For I/O, you can open up sockets, raw sockets. You can write to the file system. You have local storage, you have a built-in database. You can deal with binary data for the first time using typed arrays and blobs. You can even create multi-process applications using web workers. It's absolutely incredible. And then probably the most interesting thing is, for years I was reading about how to do web UIs, and people would write these really long tutorials on the web about how to do a perfect, fluid, responsive 2-pane layout or a 3-pane layout in CSS. And it was always like this black art of like weird CSS rules to get it all working 100% across browsers between like IE and other browsers because there were differences in the box model and the way it measured basic things like a div. And all that's changed now. And now we have this new thing called flexible box model, which I believe Daniel is going to talk about in one of his sessions, that basically makes it capable of laying out a UI just like you would in like a desktop application. It's really kind of straightforward about how you do it. And we have these new things called Scope CSS and Shadow DOM, which also Daniel's giving a talk called A Glimpse into the Future of the web, which talks about web components, which is amazing. That presentation will blow you away. And finally, all the major browsers have like accelerated GPU drawing now, so they render a lot faster as well. And I told you that GWT was created in 2006 to kind of smooth over all of the differences in the browsers. Well, an interesting thing is that since Chrome got released and sort of put all the other browser vendors on this notion that you should be auto-updating the browser in place constantly to fix bugs and features, the browsers have started to converge in capability. And so this is the HTML5test.com. It's like a suite of like 500 or 600 tests against CSS properties, API calls, HTML tags that are supported. And you can see they're starting to get closer together. And if you actually look at that green line, that represents, I think, IE 10. And if you follow it, I can't see my mouse pointer, but if you follow it over to like January 2012, it would intersect with that red line, which is Firefox. And so IE 10 in 2013 is about where Firefox was in January 2012 in terms of compliance with the HTML5 spec. Needless to say, Firefox in 2012 was not a non-capable browser. It was actually a very capable browser that most of the stuff you would want to use is in it. Most of the stuff that you see where there's still a gap is actually like bleeding edge stuff, that some of it's even still in flux. And so we're starting to get to the point where the differences between the newest browsers are a lot smaller. And so there's not as much of a need to kind of sort of introduce a layer that kind of gives you a lowest common denominator between them. And finally, the last thing that's really changed is the mobile market. So either it's happened already or it's about to happen. It depends on what studies you look at. But at least for external applications, 50% of web traffic is now mobile. And so that means if you're not building a mobile app right now, you might be asked to build one in the future. If not this year, then next. And native applications have also created this expectation in people's usage that the experience should be jank-free. People used to put up with a lot with web applications. You know, you click something, it freezes for a second, it says trying or connecting in the status bar, and you're like, okay, well, you know, I know it's going back to the web. I don't care how long it takes. It's going to succeed eventually. But now, you know, if someone's dragging something along and it hitches, they're like, nah, all right, I'm just going to go to the Apple Store and download another app. And so you really have to pay attention to the performance of your app now, because people want smooth, buttery performance in their application. So what are we going to do about this new reality that exists today? Much more capable browsers, much faster, and mobile. And that's what the remainder of the talk is. And the theme overall, I think, is fast and lightweight development. First, let's talk about lightweight syntax. A lot of people like JavaScript because there's less boilerplate, you know. And JavaScript is fundamentally, not JavaScript, but the browser is fundamentally an asynchronous programming platform. Almost every single API call in the browser requires a callback. And one of the most painful things to do in Java code is to find a callback, because you have to create an anonymous inner class to receive it. In Java 8, which hopefully, God willing, Oracle release in March of 2014, will finally give us JavaScript-like callback support. Here's an example. This is what adding a click handler to a button looks like today. The second argument is an event listener or event handler. You pass in an anonymous inner class. And really, the only important line of code in this whole slide is the line that says alert hello. But there's 1, 2, 3, 4 other lines of code there just to pass in essentially what it really does. Well, this is what it looks like in with Java 8 and also in the Quick 3.0 prototype. Essentially just pass in the alert with a little argument prefix, and that's it. Now for comparison, this is what it looks like in JavaScript currently. It's actually bigger. So Java 8 syntax is actually more terse, and I'd argue more readable than JavaScript. The second thing is targeting GWT to interoperate with the world as it exists. And today, most people do not write 100% pure GWT applications. Can I see a show of hands in the audience? How many of you guys have some third-party JavaScript library you've dropped in, like jQuery or some date picker or some other thing? Yeah, it's at least half the audience. And the Future of GWT survey that we've done, I think, was about 60-something%. And so that means like 60% of you or more are dropping in, you're finding something missing, and you're going out to the web and you're finding a third-party JavaScript library, and you're dropping it into your application. And then what you're doing after that is you're writing a wrapper around it. You're using JSON calls, or you're writing like more richer APIs in GWT to program against that JavaScript API. And we think that that's a lot of make work and shouldn't have to do that. It should be really easy for you to consume these libraries. And so we're introducing this new concept, which Daniel will go into more depth in his presentation, called JavaScript, lightweight JavaScript Interop, or JS interface. And what it does is it allows you to just call in the JavaScript release. Here is an example. This is a fake JavaScript library. It has one constructor called myClass, one field called answer. And it has one method called what is the answer, which returns the answer to the left universe, and everything is the field. Now, how would you consume this library if you dropped it into your page in GWT? You'd probably do something like this. You'd write an interface called myClass to model it. You'd have a getter for the field, getAnswer. You'd have a string, a method returns string, which is what is the answer. And then you'd actually have to implement that interface. So then you'd have a class called myClassImpl, which implements myClass, and you'd have two JSON methods that actually implement that. But you can see that this is just boilerplate. The method called getAnswer really just returns this.answer, and the method called whatistheAnswer really just invokes the same method in JavaScript. You're just copying what's being done, and it's just a waste of your time. But here's how you were going to do it in 3.0. You create that same interface to model the field and the method, and you just mark it at JS interface. Done. And if it's a property, not a method call, then you just mark it as @JS property, and that's it. That's all you have to do to consume third-party JavaScript interfaces. I'm not drinking drinks. Where am I? Okay, but I think we can do better than that, because even this is kind of make work for you. Right? You're essentially defining the same interface that exists in the JavaScript. What if you didn't even have to do this? Well, one thing I'm working on is something called zero-work interop. What if you could just take a third-party JavaScript library, drop it in the directory of your project, and that JS interface that I just showed you is automatically generated. It just reads the JavaScript in, understands what the API is, and just writes out the Java interfaces that map it. Something like that is possible. It actually is. Let me see if I can show you a demo. So first, I'll give you a quick example of a JS interface feature. So I'm going to create an interface for a button, an HTML button element. And all I need to do for that is I've added @JS interface to it. And then I'm going to come here and I'm going to create a method called add event listener. We all know the HTML API in a browser looks something like this. And now the first argument is the type of event, double click, mouse over, click, and so on. The second argument is always a callback. And so one of the things Java 8 has is it has this interface called consumer, which is basically a Lambda expression that consumes an argument and returns nothing, which is what event handlers do. So I'm just going to put in a reference to that. Oops. Oops. Native event. So what it takes is like a native browser, and it's called callback, CB. Okay. So now, down here, I've kind of commented out some creation code. I'm going to create an HTML5 button. HTML button, but equals new, create. What should I call it? Click. And then I'm going to add an event handler. So I'm going to listen to the click, and then for the callback, I'm just going to do this. And if everything worked, we should get the ability to just click on a button. Let's see here. Get to my app. Oops, not that one. This one. Okay, so there we go. And so I just called directly into the browser API without really writing any JSON code, and I defined a really efficient callback. So now I said that one of the things we could do is we could actually drop in a JavaScript library and use it automatically without actually writing one of those JS interfaces. So let me do that. I'm going to create a JavaScript library. Let's see, JavaScript file. Okay. And so this works today with Closure compiler or TypeScript application. So JavaScript at least has to have some documentation in it. And so first thing I'm going to do is create a type create.demo.reader. And then I'm going to create a constructor function, reader. Whoops, that's not right. I have to do it. Create.demo.reader equals function. This dot greeting equals hello. And then I need to say it's a constructor, and this is just standard JS doc annotation, and I need to give it a type, so that's a string. Okay, so now I'm going to create a method in JavaScript. I apologize if this looks painful because you hate JavaScript, but that's the whole point. You shouldn't have to write this. You just get someone else's work who's done this already, and you can tell I actually don't know JavaScript. I'm making all kinds of mistakes. Okay, and I say, okay, this dot greeting plus with create functions. Okay, and then I need to give this a bit of documentation. Returns a string. Okay, so now I haven't saved it yet. So what I'm going to do is I'm going to save this file and watch what happens. Hopefully it will happen. Did it happen? Or this might be one of the cases where where live coding hurts me. Okay, that didn't work, and I'm not going to hold you guys up. I'll have to figure out what happened later. I'm going to skip over this and go on to my presentation, and just watch Daniel's presentation. He will show off some of this stuff later. Okay. So, if you had seen this work, I don't know why my IDE didn't do it, but it would have generated a JS interface automatically. Here's the upside of this, right? If you use JavaScript, okay, I lost kilter because I didn't go through all the steps, but okay. Let's say that's succeeded. There's still problems with using external JavaScript libraries today. They must be unminified. So the source code you just saw that I wrote there basically could not have been an obfuscated like third-party library, like jQuery min or something, because the functions must have names that are stable, and they don't have like this weird like XW as the name of a function or something. The other thing is they live in a separate JS execution context. So your GWT app's going to live in like an iframe somewhere on the page, and the third-party libraries are going to live in like a script tag in the main page. And so because of that, dead or unused library code is not removable. So if you drop in like AngularJS or jQuery or some other library, and you only use like one method in that library, you're paying the cost of all the other stuff that's in that library which cannot be removed. So the question is, can we do better? This is how the world is today. So you'll have a host HTML page. Maybe you're using AngularJS, just as an example. And then you have a GWT application that's also living in the page, but it kind of sits in an iframe. And so one of the things we could do is we could feed the JavaScript to the GWT compiler as well as the Java code. And we could smush them all together and then run the optimizations on it as one whole, and then output a single optimized binary that includes only the stuff you need from a JavaScript library and only the stuff you're using in Java. And that would look something like this. We'd smush them together. And the way we'd achieve this is basically we'd attach the closure compiler, which is a JavaScript optimizer, on the end of the GWT compiler so that you could remove the dead code that's in the JavaScript libraries as well. And so this is pretty close to as ideal as you can get of Interop. Like almost no work to drop in a third-party library and generate an interface, and then the output that comes out of the compiler is about as small as you can get it. One other thing you'll get that you can't get anywhere else is actual type checking between JavaScript and Java. And so one of the reasons why you probably use Java and don't use JavaScript is because you don't have any type checking. If you make a typo, maybe you find out the next day that your app has a type error or some exception in the JS console. With the ability to combine the JavaScript and the Java together into one single program and then have the closure compiler and the GWT compiler look at it, they can actually verify that for the first time ever that your JS&I code, essentially your calls into JavaScript, are correct. All of this is kind of leading up to web components. And if you haven't heard about web components, you are going to soon. And web components are essentially a kind of web native template. I guess one of the ways to think about it is kind of like running UI binder in the browser itself. And all the major browser vendors are actually moving this way. They're all on board and they're adding support for web components to the browsers themselves. And what it essentially allows you to do is to create custom HTML elements. So you can create your own foo tag, and you can bind some GWT code to it. So if someone, like a web designer, drops a foo tag into the page, the code behind it is a GWT implementation, or a JavaScript implementation, or some other language. And it also encapsulates DOM and CSS in something called the shadow DOM and the scope CSS. So now you don't have to worry that some third-party component that you drop into your page might have a CSS rule like star text color red that just like wipes out the style of all the elements on your whole page. It can actually kind of put a sandbox around the CSS so that it cannot escape the component, which is really pretty awesome. And the future, the Glimpse into the Future presentation has an absolutely amazing example of this. But what this is going to allow is an ecosystem of reusable widgets and components. And so you should be able to go out on the web in the future, maybe next year sometime, and find that date picker you want, or that map component, or that address validation form. And it looks really slick and hot. You should just be able to drop that component into your GWT application. And using this new JavaScript Interop stuff, the goal is that you shouldn't have to write any kind of glue code to make it work. It should just work out of the box. I personally believe that this is where the future of web authoring is headed. Seems like everybody's on board. And I think for us not to be left behind, we have to be on board as well. So the other thing that we have to deal with is code splitting. How many people in the room have used the GWT code splitter? That's a fairly large number. And so, as you know, the GWT code splitter allows you to take pieces of your app and say that these are not needed in the initial download, they're not needed in the initial screen, I'm going to defer them until later. If you're on an internal app on a high-speed network, that might not seem like it's really that big of a deal. But if you're on a slow wireless network and on a mobile device that really doesn't have a lot of memory and takes a long time to parse JavaScript, this is a lifesaver. So the code splitter is going to be more important in the future mobile world. So we need to make it a lot better. Because for any of you who have used it, you know it can kind of be a pain. And it's kind of mysterious, and there's a lot of black magic underneath of it. One of the problems with the code splitter is that when you split off two pieces of code and say you can load them later, any code that's shared between those two components is promoted into a shared library that we call the leftovers fragment. If you've ever seen the directory on disk that has those numbered .js files, like 1.js, 2.js, and so on, the highest numbered one on there, like if you have 20 split points, number 20 is the shared library. It's called the leftovers fragment. And one of the sort of landmines of code splitting is the more and more split points that you add, the higher the probability that there's some shared code between any two of them. So the higher the probability that that code will be moved into that leftovers fragment. So you'll notice that your initial split point might stay small, but as you defer more and more code trying to get it smaller, this leftovers fragment gets bigger and bigger and bigger. And so you end up not actually winning anything, because the first time you hit a split point, you end up loading like a 1 megabyte shared library. And so that's actually a problem. So we need to figure out a way to make this a lot easier. So of course the current thing is that it's tedious to fix this. There's this thing in GWT called the story of your compile report. You might have used it before, but it basically tells you why a given fragment of JavaScript ended up at a certain split point, what caused it to actually be pulled into there. And so if you look at this report, you can kind of figure out like where the bad method call is and maybe how to move it to fix the problem. But it's really tedious to do. And it's also brittle, because you could actually then, the next day, add another line of code that all of a sudden makes another 500K of code get pulled into the leftovers fragment. So it's not even stable. You have to almost have a continuous build that watches to see that it's not actually reverting. And you also have a lack of control, because sometimes you want to say, I want this class to be in this .js file to load later. I'm telling you, compiler, you better put it in there. And it sometimes will end up not doing it. It will actually have it in the initial fragment. And so you want basically it to do what you say. And so the next generation code splitter, unfortunately Roberto, who gave a presentation on this in San Francisco, couldn't travel to Germany, but that will be online later, is trying to work around some of these problems. And one of the new features is the ability to force a split point. You can say GWT.runAsync, and you can actually give the split point a name, and that basically tells the compiler, I want that code to be put in there. I don't care what you think think's better. Put it in there. The other thing is that we need to automatically merge fragments, because when you create these fragments with code splitting, sometimes you might create fragments that are too small. Like if you code split off like 2 or 3, a really small method, you might get 2 or 3 methods in the split point. Maybe it's 1K on disk, but if you make an HTTP call to the server from like over a mobile network, you've spent more time sending the HTTP headers than actually getting the code. And so sometimes the fragments are too small. And so the compiler is going to try to pack those into a big enough ball of JS so that it's worth it to make another HTTP round trip to get it. And the other thing is, though, is that when you merge 2 fragments together, if they had any shared code, now that shared code is no longer shared. It's exclusive to this new ball, this new merged ball of code. And so that code will come out of the leftovers fragment and it will live in that merged bit. And the final thing is the support for multiple leftover fragments. So if you've got like 2 or 3 split points over here and they share some code, and 2 or 3 split points over here and they share some code, you don't have the case where the 2 pieces of shared code are all put into one giant single leftovers fragment. But really these little islands of sharing should themselves get their own small leftovers fragment. So you will get essentially multiple shared libraries. And it should reduce the overall size of this giant leftovers fragment. Okay, so essentially what I'm talking about is getting back to basics, trying to simplify the GWT development experience. First of that I've talked about already is radically simple or JavaScript interop. You should be able to go out to the web ecosystem and consume whatever you want, and it shouldn't take a lot of work to do. Second thing is trying to target modern browser capabilities. There's a lot of stuff that's just built into the browsers now, and we should just expose that to you, and you should just be able to use it and just assume that it's there. And then the third thing is an emphasis on mobile. Because the mobile devices are basically more numerous than the desktop devices now in terms of the number of users, and the devices themselves run the latest HTML5. There's no mobile device out there that's running IE6. Got it, you know. So that's good to know. So I said the theme is lightweight and fast, and so I covered lightweight development already. I wanted also to talk about fast. As I said, GWT was designed for 2006, and that primarily meant we had to actually fix problems with browsers like Internet Explorer. We had to design for the speed and the JavaScript VMs that existed 7 years ago. But the world has changed a lot. And one of the things we found out is that we are generating code that's slow on the modern browsers. As an example, Daniel worked a lot with the new Google Spreadsheets team, and we found out one of the things that's really slow in GWT is creating arrays. Much slower 10 times slower than it needs to be, actually, right? It's 10 times slower. And so Daniel did some work on that, and he fixed it, and now they're like 10 times faster. But we can go a little bit further. For example, if you are creating numeric arrays, like an array of integers, we should be able to leverage the new typed array support in the browsers. These are like typed JavaScript objects. And one of the interesting things about it is their performance is equivalent, if you know C code, to like a malloc and a C pointer dereference. Like literally, dereferencing that new int32 array is basically equivalent to like star pointer. It's very, very fast, and this is why Mozilla has based their ASM.js stuff where they're running like Unreal Engine 3D games in the browser on these typed arrays. They're very, very fast. But we can also tune the code generation for the modern VMs, like V8. We have also discovered that we're doing things that sort of inhibit the optimizations in the V8 virtual machine. And so we're looking at fixing that. And we may even go with outputting ASM.js-like code for increased performance, like adding actual like type annotations into JavaScript that help the VM speed up the code. And we're looking at getting even smaller JavaScript by utilizing the Clojure compiler backend a lot more. There have also been performance improvements to layout in the browser, and we want to leverage those. A lot of GWT layout stuff is based on using JavaScript code to construct a layout, like creating horizontal flow panels and vertical flow panels and things like that. And those actually slow down the browser a lot. What you really want to do is you want to leverage the native C++ code in the browser for layout. And so things like flexible box model allow you to do that. So we want to look at adding new APIs or implementations in GWT that leverage things like flexible box model, CSS stuff. We also want to add support for CSS3. Some of you have maybe been frustrated by CSS resource and client bundle. The fact that maybe you wanted to use some new fancy WebKit transform or 3D transform in CSS and you haven't been able to do it, or you get syntax errors. There's a talk here today that kind of shows the new feature, which we call GSS resource, that enables CSS3 in a browser. Then finally, we want to try to modify the SDK to avoid constructs that lead you to janking a browser. I don't know, because most of you are German speakers, if you know what jank is. I don't know if that's an American term, but basically it just means frame rate stutter when you're moving around in the application. But I know the thing that's irritating you guys most, we hear this internally, we hear it in the surveys, we hear it everywhere, is the compile time. You must have faster compile time. It's a serious drain on your productivity to edit code and then wait minutes to see the result. And so there was a presentation given in San Francisco on the next generation modular incremental compilation stuff that we're working on. Ultimately, we're hoping to get the speed of compilation proportional to the number of changed files. Right now, it's proportional to the number of modules that have been changed. But essentially, if you edit like one .java file, where we want to be in the future is, it recompiles that one file and then reloads the page. It doesn't recompile the entire world as the WIP compiler does today. I don't know if anyone here is doing a session on that, but there will be a video, I think, and you can actually see. I was actually giving a presentation when one of my colleagues was actually showing it off in another conference room, and the applause was so loud that I actually had to stop for a second. And so that's how impressive it is. Okay. And then the other thing, though, of course, is for draft compiles, that's great. When you're developing, the draft compiles will be like really fast. But we also want the production compiles to be faster, because some of you have continuous integration build systems, and you check in some code, and then thing goes, runs all your unit tests, and it does your build and pushes it to production. You want that to be faster too. And so there's also an attempt to design a new, what's called split local global optimizer. There are some optimizations that the compiler does, where it only really needs to look at one file, and there are some it needs to do where it needs to look at the whole program. And what we're doing is we're looking at splitting those up. So the ones that are purely local, we can run multiple threads on multiple machines, we can parallelize it. And the ones that are global basically kind of occur at the end, and it should result in a faster global compilation to production. We're also trying to improve SuperDev mode. Okay. As people know, we're having problems keeping dev mode alive because the browser vendors are yanking the APIs that we use for our plugin out of the browsers. And they're doing it for various reasons. Some of them have to do with security, some of them have to do with performance, but we're losing the APIs that we use to do regular dev mode. And so we had a backup plan, and that was SuperDev mode. And I actually like SuperDev mode a lot, but to be honest, we do have to improve it. It needs to be significantly faster in refreshing medium to large applications. We need to have a better debugging experience. You need to be able to, in your IDE, set breakpoints in your Java debugger and actually be debugging against JavaScript that's running in Chrome or running on some other device. But even given the mobile future, this makes a lot of sense, because there's a snowball's chance in hell that Apple is going to give us like a plugin API to run with dev mode on the iPhone. So you can imagine if in the future you're tasked to do a mobile web app on the iPhone, if we didn't have SuperDev mode, it would practically be impossible for you to have a dev mode debugging session on an iOS device. And so really this is the path going forward, SuperDev mode. Brian's doing a session later talking about that. Okay, so overall, fast. We're trying to increase the speed of round tripping in your compile cycle. We're trying to increase the JavaScript execution speed, and we're trying to look at making the browser render a lot faster and avoid jank. So the final question you might have is, when is all this going to happen? As a general disclaimer, everything you've seen here today is not guaranteed to make it in GWT 3.0. A lot of this stuff is very alpha, it's very much in a prototype stage, and we're not sure. It depends on the steering committee, and it depends on what we agree on is going to be cut for that release and which might be saved for a later point release. And so, that said, the next release of GWT is tentatively scheduled for sometime in mid-2014. That's usually where we would do it sort of on a yearly basis, because GWT 2.5 was released last summer. What I'd finally like to say is, I'd like to ask all of you to get involved. So if you're actually interested in helping me add Java 8 support to the browser or add some new APIs or support web components, please go to the GWT.project.org and look at how to contribute. More than that, there's actually a workshop, I believe, here that will actually take you through submitting a patch to the GWT SDK. So if you're actually interested in learning how to actually contribute, that's an excellent presentation for you. Thank you very much.